Hello and welcome to another episode of the Clojure Pills screencast. This is episode number 8. We are going to see a very important macro in the Clojure standard library, actually the mother of all the macros, which is defmacro. But before we start, a quick mention of the book I'm writing for Manning, the Clojure standard library, an annotated guide. The content of the screencast is roughly based on the content of the book, so if you enjoy the screencast, you might very well enjoy the book as well. This is the link to the book if you want to check it out, and below is my Twitter handle at reborg if you have any question. Let's get started. So macros is a quite large topic. There's plenty of articles, blogs around the internet about macros and specifically Clojure macros. The intent of this screencast is not to go into much philosophical details about macros, so it will touch on what a macro is, but I want to concentrate on the Clojure facilities behind the defmacro that let you define a macro and how you can use it. If you need a little bit more background on macros, I can suggest a couple of books. Mastering Clojure Macros by Colin Jones is a very nice and short book dedicated to macros. It's easy to read considering the topic, so I highly recommend that as an introduction to macros. And the macro chapter on the Joy of Clojure book is also another very good resource. Those are the links to the books, and they are also easy to find on Google if you search for them. So I prepared a little example here to guide us through macros in Clojure. So let's say I want to create a debugging tool, and this debugging tool is something I'd like to use to see intermediate results of more complicated forms. For example, let's say I don't understand what is happening with that +1,1 in the middle. I'd like something that can be put somewhere in the form that is printing that intermediate results and is always is not changing the construct of the function, is always returning 0.6 like in this case. So I come up with one first attempt. I call it like question mark function, and the idea is to use it like so. I put the question mark just before the form I want to inspect, and since I want to be able to see what is inside the form without Clojure evaluating this before passing the argument to the question mark, I'm thinking that maybe if I wrap it inside an anonymous function, I will be able to see what is inside the body of the function. Problem is, as you can see from the printout, that the result is printed correctly, so I can see that the intermediate result is 2, but when it comes to what was the form that evaluated to 2, the only thing I can see is this this long string of numbers and other strange symbols that I don't understand. So maybe this is not the correct way to operate. So it looks like even if I'm wrapping the function, when the wrapping function is evaluated, also the body of the function is evaluated, and I cannot access the sources as a string anymore. So I think I can do better, and then I come up with another way of doing the same thing. Is again the question mark function, and I think that if I'm able to suspend the evaluation by quoting the form, maybe I'm able to see what's inside the form. And apparently that is correct. So now I can see that I can print the form +1,1. But when it comes to the results, there's something strange happening. So +1,1 is 1, which is of course not true. So what's going on there? Let's check it out. If I do what the function is doing for me, so the first of +1,1, I can see that the first of +1, I can see that the plus sign when I extract the plus sign is a symbol, is not what I would expect, like a var or like any other kind of Clojure function, but the symbol is actually a function, and so I can invoke the symbol with 2 arguments, and it's printing 1. And why is so? I can check it if we briefly have a look at the sources of Clojure, the symbol.java class, and I can see that there are 2 ways of invoking a symbol. One is with a single argument and one is with the 2 arguments, and we are invoking the one with 2 arguments, I assume, and the logic for this invocation is for the symbol to check in the internal symbol table to see if the object passed in is present in that table. And the number 1 is of course not present, so what it is returning here is the default, which is not found. So I can verify that. I can basically pass anything and will be returned back to me. So this is clearly not what we want. What we want is a way to transform that symbol into something that can actually invoke, and I can do that by using nsresolve in the current namespace of that symbol. If I do that and I try again, I can see that now the form is printed correctly, the result is 2 as expected of the intermediate result, and also the final result is the same as expected. Good. So let's see if we can do something different. We can do something more with that. One typical case is I might want to use the debugging macro for other inner forms, and the debugging macro might be present, it might be not. So what I mean is that beyond the fact that I can extract the first element of a list, the rest of the list could be any level deep indentation of other forms. And so my little Clojure parser here, nsresolve, it's failing fast if I'm using nested forms, and I can see cast exception when I try to cast something that is not a number, like this question mark into a number. So are there better approaches? Of course there are. And one of them is to use macros. And the way you can use macro, one very basic way to use a macro is to keep your function and to turn on the macro flag on the function by just invoking it on the var object. This is not the way I suggest you should do it, but is to prove or to show you how the macro facility work. So I define again the question mark function for debugging, and I set the macro flag on. With this, by telling the Clojure compiler that this is a macro, then the Clojure compiler starts to behave differently. It takes a different branch. It stops at the analysis phase. It might recur on the analysis as many times as there are macros until there are no more macros, and then is kind of returning back the expanded state of a macro without actually compiling the function down to bytecode and a Java class. For this reason, when I now invoke the debugging macro, I can just pass the form as is. I don't need to quote it, or I don't need to do strange wrapping with other functions, because that will be unevaluated, and I can then print it and see the results. For this reason, for the fact that the form is unevaluated, I need to evaluate it explicitly. As you can see here, I need to use eval to actually return the results, but then I can print what I need. So let's see if it's working, and I can see that it's working fine, and now it's finally working also for nested form if I need them, so I can see double prints now for 2 intermediate results and the final result. Are we happy? Well, maybe. So we need to do this explicit set of the macro flag that I might forget about, and I also see these 2 implicit arguments that are passing through that I don't maybe I don't exactly understand what they are doing there and why they are there. Is this like a general case, is good enough for any kind of problems I might have with my debugging macro? Unfortunately, the answer is no. And the reason is, for example, one possible reason for this is the accidental capture of local bindings from the outside context to the macro. So you can see that I'm calling, in my macro, I'm calling the evaluation of the form res and as a local binding to the macro. In this example, I've also have an outside res local binding that is set to 5, and the intention of that is to sum the number 1 to 5 and then see the intermediate result. But this results in a not very clear exception. Let's try to see if we can explain what's going on there. So we can, in this expression that we are showing here, we can replace the content of the macro inside the expression, and we can replace form local binding of the macro with the actual parameter that we are passing in, which is the list plus 1 and res. When we put it in that form, you can see that we have an outer local binding res and an inner local binding res. The problem is with the inner one, because we are trying to eval a form that contains a res symbol, and when eval evaluates, it has an empty context. It doesn't know about local bindings out in the outside world. So when it tries to evaluate this form, this res symbol is unknown. And we can see, if we just try to evaluate this specific part, you'll see that this eval is returning back saying, I cannot find a way to resolve the symbol res in this context. And there is a better approach, actually a correct approach. We are going to introduce two things, and one is one feature of Clojure called syntax quote, which is this backtick. When we introduce this backtick, we have access to loads of other tools, and Clojure is enforcing hygiene in macros when we use syntax quote. Macro hygiene is like a common term that you might hear that is collectively describing all the practices or the tools that the languages provides to you in order to avoid accidental capturing of outside the context and local bindings. And it's also, so if you, for instance, if you try to define a local binding without a fully qualified namespace, it will complain, it won't let you do that. And for this reason, it's also providing you with a tool which is called automatic generation of symbols, AutoGenSyn, which is this pound sign at the end of the res, which is basically is expanding res into a name which is unique with a number attached to it that you can see sometimes when you do macro expand. And it's also giving you a way to temporarily exit from the quoting part of the expression and going back into evaluation with the tilde sign, which is called unquote. There is also unquote splicing that we are not going to see today. And thanks to all of this, we can now try to evaluate again. And finally, we are also able to fix the problem of accidentally capturing outside scope or trying to evaluate symbols that are not in the scope of the eval. So I can now stop using explicitly eval. I still have to set the macro flag explicitly, and I still have these two mystery arguments. Finally, Clojure has this defmacro macro, which is a macro itself, and this is what is nicely wrapping all the discussion so far in what you know as a macro definition in Clojure. You don't see, if we now use the def macros to define the debug question mark used to be function, now macro. The two mystery arguments are disappearing, and we can use syntax quote as we were able before. And another important thing, we are not forced anymore to set the macro flag in an explicit way. So we can try our new macro, and let's evaluate this. We can see that it's working as before, and now we can also reveal what the two mystery arguments were. When you use defmacro, Clojure is implicitly passing to the body of the macro. You're writing two arguments called &form and &env. &form is the unevaluated form as it was read by the Clojure reader, and is passed to the macro, and then you can use it in unevaluated form to print it, for example, or to even evaluate it as just a list, right? So if you take the next of the list that contains now the question mark, well, it's probably better to show it. So if we evaluate this and we try again our snippet, you'll see that instead of printing just the inner form +1 res, we are also printing the macro invocation question mark with parentheses. So if we skip that with next and we take the first, we have just the +1 res form, and we can evaluate that, which is what I'm doing here with fnext of nform and unquote. For this reason, I don't need anymore the form that is passed into the macro. I still need a placeholder argument, because I'm still calling the macro with one argument, but I'm only using the implicit arguments, only the first one. &end is instead a map of all the local bindings at the invocation call site of the macro. We are not using it here in this specific instance. So how does it work? It's useful to see that defmacro is just invoking defn with this simple macro with nothing in it. It's just invoking defn with the symbol simple that will be defined, and you can see now that when the defmacro is macro expanded, you can see the two arguments, the two implicit arguments that are passed in to the body of your macro. You can also see that what is happening inside is just the macro flag is set exactly the same way we were doing it before, and finally the var is returned, which is the reason why when you evaluate the macro you see the # quote user / appearing on the screen. For this reason, for the fact that defn is basically what defmacro is doing underneath, you can use all the facility of defn to define a function in a macro. So you can have metadata. Now I have a debug equals true metadata here. I have a docstring. I have two arities. I have preconditions. This one, for example, is saying the form must not be nil, and then the rest is the same as before. So if we want to see what happens when we evaluate the new question mark macro, we can see that now is going to refuse to evaluate a nil because the assertion, the assert is failed, and we also have the new facility, the new option of passing in another function for printing, which is not a print line, but in this case, for example, is the pretty print right. Final, I just want to briefly touch on defmacro performances. So sorry for that. This is the source of defmacro. You can see that what it's doing is it's basically preparing the arguments that you are passing in for the final defn invocation with that declaration. So considering that there is a harder limit to maximum 18 in this case, with the 2 implicit arguments, 18 arguments total, this is really like a constant time operation. Also important to remember that macro expansion happens at compile time, so you won't see this overhead during runtime. You will see it at compile time, but again, in order to have problems with defining macros, you have to define way too many of them, like 100,000 or so, and then it means that you will have serious problem of compiling the program. It doesn't matter if you AOT compile it or not. But that is not usually the case in normal conditions, so you shouldn't be concerned about using defmacro in terms of performance impact on the application. I think that was all I wanted to say about defmacro. I hope you enjoyed the episode. The show notes will be available on the Clojure Pills GitHub project, that you can see the link here on the screen below. I hope you enjoyed the screencast. I hope you enjoyed the macro explanation, and until next time, goodbye.